All right, today we're going to do weekly challenge number 6. All they want you to do is they want you to take a look at, hold on, let me pull the results window up. All they want you to do is take a look at all the cities that each rep has traveled to and calculate the distance and then figure out which one of the reps traveled the longest. Okay, that's the short version of it. And what they've provided you is the city name, the centroid or the spatial object, the rep, and also the order in which they traveled. And the order is important because, kind of by nature of my experience with the tools and also where we're trying to go, the order is important because it dictates the shape of the polyline. And if this is not in the right order when it draws the line, for example, like let's just say that because of this order, it'll draw a nice straight line. But if you switch it up and renumber this like 1, 2, 3, 4 in the middle, it'll create like this weird spider web effect. That will affect the calculation for total distance. And so that's why trip order is important. But bit of an off topic, but yeah, so they provide you these 4 fields, and what you're gonna have to do is you're gonna have to use the spatial tool ribbon. Obviously not all of them, but you're gonna have to use the spatial tool ribbon. And so by nature of the tools that we're using, I would classify this problem as intermediate, but if you have knowledge of spatial tools, it is a really easy problem. If you can't tell already from the data provided. It's intermediate just because the spatial tool, like some of these other ones like machine learning or SDK, is not the typical ones that most Alteryx users use. They typically stay within these 5 bands right here from in and out all the way to transformation. So there would be a bit of a learning curve to figure out what each tool does and getting your head around the idea of spatial objects. So yeah, but once you know how to use spatial objects, it's like the whole Alteryx program, it's very straightforward, it's very user friendly. Okay. So what does the data look like in absence of anything? So like I said, this spatial object field right here is essentially points. Underneath the wrapper is a list of coordinates. So you can't see it here in the results window, but if you look at the text input window, you can see what's underneath the wrapper of the spatial object. So if you see here, it's like a tuple of information. Would you call it a tuple? Maybe not, but essentially it tells you what kind of data it is. It tells you the variables and what they are, and then the values. So in this case, it tells you that it's a point with coordinates this and this, longitude, latitude, okay? And so right now in itself, all it is dots, right? So we need to find the total distance from beginning to end of the travel path of these reps. So we're gonna have to create lines, okay? Specifically lines per rep. And knowing that really for spatial objects, there's only one thing you can use, which is the PolyBuild tool. The PolyBuild tool builds polygons, if you will. But in addition to polygons, it can also build polylines. Polylines being many lines. I don't believe any other tool does that. Distance is kind of, I'll get a distance after I think solve it, because I think when you look into this, distance is like the immediate, I think, knee-jerk reaction to finding who traveled the longest. But there's a lot of nuance to it that I'll get to after I solve it. But in short, PolyBuild is what you need to use. It builds polygons, but in addition to that, it also by chance does polylines. And so if you bring the tool down and you hook it to the data input, the default is convex hull. In short, convex hull and sequence polygons are both polygon results. What we're going to need is sequence polyline. The PolyBuild config has 4 options. The 4th one is grayed out by default because we're on convex hull. But if you go to sequence polyline, it will activate and you can fill in. And this sequence field is important once again because if the sequence is not correct or in the way that you intend it to be, it will count the distance incorrectly. Okay. So source field is pretty simple. You just need to give the points you need to give it where the points are. So in our case, it's central. It all detects any spatial objects. So in this case, it got it correctly. But in case you have many others, you might have to select the right one. Group field is important too because this is what dictates what's a polyline versus one singular line. What I'll do is I'll leave it blank just to show you what happens. And then sequence is the trip order. So let's run it now. Okay. And in absence of a group, what you should see, oops, I didn't add a browse to, what you should see is one mess of a line, okay? So we run it again, see here, it's just one big line. Another note, if you're getting this white screen, for me, it defaults to this. It just means you don't have a base map activated. Just click on this and pick whatever. I've not invested enough to really look at why it doesn't by default stay on a base map. Maybe it's for processing, on a resource saving or what have you. I don't know. But if you see here in our results window, what you have here is after we told Alteryx that we want to build a line and we told them all the points and the sequence, what it did was it just connected all of them because that's what we told it. Which is why you need to, I mean, if the intention is to split it, why you need to dictate a group field. In our case, it's the rep, okay? And when you dictate that and you separate it, it may not look like much. It may look the same, but in reality, I mean, here's a good example. If you see here are two obviously separated points. I don't know if they're the same ones. They're probably not. But my point stands that, I mean, there are multiple endpoints, which means that there are multiple lines here. Okay, it's like 1, 2, 3, 4. Okay, so it's clearly not one singular line, is what I'm saying. And that's the intended effect when you use the group field in addition to the other ones, right? So, so there's that. You've built your polyline. So really, we're at the doorstep of the solution. All we need to do now is measure the distance. Now, like I kind of alluded to earlier, if you have no familiarity with the spatial tool ribbon, you might look at the distance tool and go, oh yeah, why don't we do that? That's not going to work simply because we have multiple lines, and that's really the only hiccup. Let me think about that. Yes and no. Distance is truly, I think, at its most simplest. It needs 2 points. That's the only inputs. So that's also I would say the limitations of the tools why we can't use distance for the next step. And also by nature of our data set, which is we have multiple lines, why you can't use distance. And so yeah, to kind of wrap that up, distance might be your gut reaction on how to do the next step, since we are trying to measure how far everyone traveled, but just by nature of the tool, it isn't. So there's that, without me over repeating myself. So with that said, the next thing you got to do is calculate the distance. What we're going to do is we're going to use the spatial info tool. It's very similar to the formula tool. There's a lot of really cool functions baked in, but other than that, you can't really type in any expression functions. So in this case, we want to find the length in miles. Although I don't know if they indicated miles, has logged the most miles. So we're going to do length in miles, and we're going to indicate which object is a spatial object. In our case, there's only one, so that works out. And then we just run it. Okay, we run it, and we see that here are the miles, okay? But we want to know the most. So the next thing we do is we want to sort. I mean, you might want to try to summarize it, but because there's so many people, you can't really sort by the most. If you try to do max length, they'll give you the max number, but it won't tell you who the rep is. You might have to jump through hoops if you want to use the summarize tool. Like you'd have to do some concat function probably to truly bring it all together. But we don't need to do that. We just need to sort it. I mean, we can half-ass it, I guess what I mean. Sorting it will work in that aspect. So we sort it by length, by descending, so that the first row should be the winner. We click on it, and what we'll see is that Diana should have been the most. She traveled 9,000 miles. We look at the solution. Diana is 9,000 miles, okay? Now, this all works out because we only have 7 solutions, but had you had more, yeah, that's right. Had you had more, what I like to do to check whether I have the right solution is, as part of my QA, I love to join and to duplicate. And so what I'm doing here is, in theory, if my solution is the same as their solution, when I join them, when I union them and stack them, and then dedupe it, it should split exactly by half. And some people, they do kind of QA through joining as well. But the benefit of doing this way is less clicking. And what I mean by that is when you do unique, you can just do select all, and it does all of that work. You can do that with join too, but I'm getting too much into the weeds. This is just my preference, union and then unique. Okay, so let me just quickly run through the QA check for you. So we're getting 7 records from the solution that they provided. I am seeing 7 records from my solution. So I'm going to stack it, dedupe it, and say, hey, look at everything and tell me if there's any duplicates. And if things work, it should be exactly half-half. Okay, so I'll run it. The union tool shows 14 records, so it's stacked perfectly. Eyeballing it, it looks the same. We go to unique tool. something's wrong because the unique tool has 13 records and the duplicate only has 1. But eyeballing it, it should be the same. Kathy is the same, line object is the same, numbers are the same. But here's kind of the red flag. Like you see all these red, this red tick in the corner of the box. That's an indicator of trailing numbers. That's an indicator that Alteryx, for our sake, has rounded off just to fit within the box. And because of that rounding, and because they're coming from 2 different sources, and because they've gone through 2 different transformations, there's a high chance, especially with numbers in certain formats, that probably somewhere like a billion digits down the road, there's the difference. Okay, which is why this unique tool is not working. And so I recognize that I'm kind of digressing now into quality assurance, but just to prove my point, if I remove length miles, I bet you that if I run it, it's gonna do by half. Okay, so if I run it, it starts with 14 and we get 7. So that means at least on just the names and the spatial objects, they're all the same, but the length mile is what's holding it up. And going back to what we saw earlier, eyeballing it, the numbers are effectively the same. It's just somewhere in the end is wrong. And so if you want to fix that, because numbers is a common hiccup, just reformat the numbers. So right now they're both coming in as doubles, but they may not truly be doubles, or at least they've been formatted as doubles in a different way. So just do it again, just leave it as is. Just tell it to reformat again. And then what you'll see is it comes in again and then should, oh no, it didn't. Oh, you know what? Let's give it something truly unique. We'll just do a float. Try that. There you go. So yeah. So if you truly do change the data type, it'll probably fix things because it'll apply the same transformation to both. And given what was coming in, and given how if you look at everything, the numbers are essentially the same, chances are whatever difference there was is so far down the road in the decimal places that as you change the data type, you retain most of the original knowledge. So that was a bit of a detour in terms of QA, but as what I've shown here is because it split down the middle, half, 7 records each, I truly did find the exact same solution as they did. Okay. And so to quickly rehash, they gave us a bunch of cities, they gave us a bunch of spatial objects, the reps, as well as how they traveled. How do you find the length of the distance of their journey path? Well, you just have to build a bunch of lines, and the only tool to do that in Alteryx is the Spatial Objects tool, specifically the PolyBuild tool. Okay, and then to find the distance between multiple lines separately is to use the Spatial Info tool, in which you just select what you need. Okay, and that's really the guts of the problem. Now, one slight related detour will be is me kind of explaining the distance tool. So if I click on this, what you'll see is you have 2 points of measure, and that's really the main limitation here. So could you have used it with this still? Yeah, but it would have been super tedious. And what I mean by that is, given that the distance tool can only measure 2 points, you would have had to split each one of these. You would have measured each point of these separately in a different tool, 1 to 2, 3 to 2 to 3, 3 to 4, so on and so forth. And so to prove my point, just to show you how to do one, and I'm not going to do all of it because it would bore you to death, but let's see. Let us split on Kathy. Okay, we'll start with her. Okay, Kathy. Okay, so we get into Kathy. But here's the thing. This thing takes field records in, right? And if you look at our input thing, if you look at our input, our centroids are all collapsed in one field. We need them as separate fields of their own. So what we're gonna have to do is we're gonna have to go to the transform, and we're gonna have to do a crosstab transformation if we want to use the distance tool. So we'll do a crosstab here. So once again, crosstab is taking something that is vertical, making it horizontal. So because we need these XY values horizontally as values by themselves that we can calculate, we're going to transpose them by their trip order. So on top, we're going to have it be labeled trip order numbers 1, 2, 3, 4, 5, 6, and the value for that will be the centroid. So the column headers will be trip order. Values for the new columns will be centroid. The aggregate value the way of aggregating will be just take the first value, and then we're going to group it by the rep name. All right. I wonder if you don't group, will it still work? Yeah, it'll still work. Yeah, you don't need a rep name, so you don't have to do that. Okay, so then now we're primed for measuring distance because now we have each point as a separate field. So we connect it to here, okay? And we will do, so now we have to do, give me the two centroids. So we're gonna do connect 1 to 2, output distance, and then here's some other nuances in the distance config window. If it's 0, or if the point's outside the polygon is inside the polygon, give 0. It's not relevant, it's not a polygon, so I don't care. Output drive time is not relevant, I don't care. Output cardinal direction, I don't really care what direction this is heading, so I'm gonna unclick that. Units miles, so that's fine, and we'll run it. If you run it, what you'll see is, so here's all your original fields. The way it works is they'll output the distance all the way at the very end. So if you scroll here, the first distance is 723 miles. And so let me think about this. What would be the easiest way to do this? Do it horizontally or vertically? Okay, so what I'm thinking of is how do I verify that this works as effectively the same way as this one, essentially the same way as that one? I'm gonna have to calculate all of them, but what would be the quickest way to do that? It doesn't matter, I'll just stack it. So we're gonna do it this way. It's not gonna be pretty, but it'll work. So we'll do this. Oops, a dork. Just need to do this one. Okay, so now we find what number 2 to 3 is. So on and so forth. Okay, so I'm basically counting each individual segment. So 1 to 2, this will be from 2 to 3. This one will be 3 to 4. This one will be 4 to 5. This one will be 6 to 7. And I believe that's it, right? Yeah, that's it. Okay, and with each disappear. And with each process, it should produce a new output window. So at the final one here, there should be, I don't know, 14 windows or something like that. So here we go right here. So now here's the moment of truth. Let's find out what that total distance is. And in theory, if this is correct, it should match with whatever Kathy has right now. So to add all that, we're gonna have to use a formula tool, of course. And then, so we'll create a new one, call it total distance. And then basically we just add it all together. So what's the name of all these new columns? Distance miles. All right, so distance miles plus. Okay, that works. Just for giggles, I'm going to create a new one called rep and just call it Kathy so that we have something. This is just to make it look nice. Okay, we'll run it. And also, there's going to be a lot of junk in here, so I'm going to add a select tool in here as well. And I'm just going to deselect everything. And I just want the rep and the total distance. And we'll move that down. And then there. So Kathy should be 6386. Let's see what she got here. Oh gosh, 6770. That didn't work out. Am I missing a number? Kathy has 7. 1 to 2. 1 to 2 output distance. 2 to 3. 3 to 4. 4 to 5. Oh, I missed something. I knew it. Duh. I am missing 1 point. So 4 to 5. 5 to 6. 6. 6 to 7. Now you might be wondering, like, why don't I just, I mean, if this is a question, why don't I just do 1 to 7? Simply because that only works if it's a straight line path. In this case, a little bit more real world, you do zigzags. And so if you only give it 1 through 7, it's only going to plot, from 1 to 7. So if we look at something like this again, let's just assume that this is 1 to 7. Let's just assume that Kathy path is like this. She zigzags down the north, the west coast. Well, if you just gave it 1 to 7, maybe Washington is 1, Arizona is 7, it would just calculate the straight line difference. So that's why you can't just do the 1 to 7. So now that it is doing that correctly, let's do distance miles. It should be a 6 now. Okay, so let's try that again, and hopefully that should work. So recalculate. Kathy should be 6777. Well, that doesn't sound right. Oh no, it's close. All right, cool. Kathy is 6777. So yeah, we got it right. And then actually, if we want to double check this, and this is just overkill now, we could join it. So join it, join this one coming in, and we'll join it by the rep name. And we'll just bring in the distance and call calculated distance. And then we run it. If we want to really check, look at the joined ones, we'll see Kathy joined with the right one, and it's effectively the same number. So yeah, that's why the solution is using the PolyBuild tool, not so much the distance tool, because of that distance limitation. So yeah, that's it.